When working in the lab, things can be a little dangerous. In fact, you could even say that things can ramp up pretty quickly. As you might have guessed by the title of this video, Wellesley College employs the RAMP method to reliably reduce the risks of working in the lab. RAMP stands for Recognize the Hazard, Assess the Risk, Minimize the Risk, and Prepare for Emergencies. You can employ RAMP in any situation in which case you might encounter a hazard. Why, just take a look at Wendy.
Hi, I'm Wendy Wellesley.
And Wendy has decided this year to travel abroad in the Amazon. Unfortunately, that means that she might encounter some alligators.
Good thing I know how to use RAMP though. First, I recognize that there is a hazard, a caiman to be specific. Then, since the hazard is the caiman, I assessed my risk. My risk include being bitten and dragged. So to minimize the risk, I'm just gonna keep my distance and walk away slowly. But just in case that caiman does come, I prepared for the emergency by bringing a bag of bandages and a big stick to fight him off.
Great job, Wendy. You used RAMP wonderfully. Your analysis and mitigation were especially successful because of your background knowledge. However, while it's pretty easy to infer that an alligator is dangerous, lab hazards are a little more tricky. Luckily for us, OSHA has provided us with a globally harmonized system for classifying hazardous chemicals, which does a lot of the assessment beforehand. Well, that might sound a little complicated at first. It's actually pretty straightforward. There are 9 symbols that you need to know. Health hazard, which represents that the substance is toxic or will change your DNA in some way. Without proper handling, these substances can be a proper danger to your personal health. The flame symbol is more straightforward, accompanying all substances that are easily capable of starting a fire, either by being flammable, self-heating, or highly reactive. An exclamation mark has a similar meaning to the health hazard, but is of less immediate danger. These substances will be irritants, skin sensitizers, acutely toxic, have narcotic effects, serve as respiratory tract irritants, or cause damage to the ozone layer. A gas cylinder is exactly that. This symbol means that you're dealing with a substance that's under pressure. The corrosion symbol tells you that a substance is corrosive, causing skin burns, damage to your eyes, and it has the capacity to corrode away metals. An exploding bomb explodes. These are self-reactive agents, including organic peroxides. A flame over circle tells you that the substance is an oxidizer. Conveniently, it also looks exactly like an O on fire. The environment symbol, unlike all of the other symbols, is non-mandatory, and thus it might not always show up. This means that the substance, if poured down the drain, will be toxic to aquatic wildlife. However, many substances that are toxic in this way may not have this symbol. So never pour anything down the drain unless you have express permission from your instructor. Finally, the skull and crossbones means acute toxicity in a severe or deadly capacity. Anything that has this symbol should be dealt with extreme caution. As long as you know what every symbol stands for, your assessment job is halfway done. The other half has to do with looking up the safety data sheet for every single chemical that you'll be working with in the lab. This will tell you exactly what personal protective equipment you should be wearing. This is a safety data sheet, and it will list outright the specific hazards of a substance. You can find the SDS for any chemical on the Environmental Health and Safety website, or using Google. They're created by the manufacturer of the substance and are always available. Finally, you need to take a look at what equipment you'll be working with. Are you working with heat? Glass? Sharps? Electricity? You need to keep all of this in mind when making your assessment. Let's try applying RAMP in a real-life lab scenario now to review. Use a pipette bulb to transfer 10 milliliters of the barium hydroxide solution, which is caustic, into a 250 milliliter beaker. Add 50 milliliters of distilled water. Begin stirring the solution with a glass stir rod. Measure out approximately 60 milliliters of 0.1 molality sulfuric acid, which is a strong acid, into a 250 milliliter beaker. Set up a ring stand, burette clamp, and a 50 milliliter burette to conduct the titration. Rinse and fill the burette with a sulfuric acid solution. Titrate the solution with the sulfuric acid until the solution changes to a deep green. Use a hot plate to warm the beaker of mixture containing the barium sulfate precipitate to a near boiling temperature for about 5 minutes. Allow the mixture to cool and then filter using a ring stand and filter funnel. Dry the precipitate and filter paper in a drying oven for at least 15 minutes.
I've assembled together a team of very experienced researchers here at the Science Center to talk about what they would do themselves in this particular experiment.
Well, I took notes while we watched Wendy perform the experiment and noted all of the hazards. She's handling a caustic substance, a strong acid, and a boiling solution. She's also got glassware and a hot, powdery precipitate to move around.
Well, she's at real risk for chemical burns from the caustic substance and the acid.
Or a burn from the heat of the hot plate.
Or the boiling solution itself.
Right.
I don't really get how the glassware is an issue besides getting burned.
Well, if she drops it, then there will be shards of glass everywhere, and she could cut herself.
That makes sense. But if she cuts herself on the glassware that's covered in solution, won't she accidentally have it injected into her body?
I mean, I suppose so, technically speaking.
Plus, if the powder's fine enough, she could accidentally inhale or ingest it.
Yeah, that's just another way for her to get poisoned.
That's all pretty great, but what if someone makes a mistake? In the case of a mistake, it's all too possible that you might end up with an emergency. And that's why it's vitally important to recognize the P in RAMP. Prepare for emergencies. There are multiple things you can do to make sure you do this. For example, you need to familiarize yourself with the emergency poster located in every single lab. You need to know where the 2 exits are in every single lab. And you need to know Campus Pose extension by heart. There is an automatic external defibrillator, or AED, near the leaky beaker. You should also note where the nearest emergency eye wash, emergency shower, and spill kit is located. Here's a hint, there's always one nearby.
Now that you understand RAMP, you can be sure to stay safe in the lab. You should feel very comfortable recognizing the risks, assessing their dangers, minimizing the risks, and preparing for future emergencies. With this basic understanding in place, we strongly encourage your instructors to go over any particular risks that you might encounter in your laboratory, so you can keep them in mind. Stay safe, everyone!